So we have a problem about a printer. It says the table and the equation show the rates at which two different printers, in terms of page per minute. What is the difference between the per page ratio of the two printers? Which printer is faster? That's what we're going to find.
So we're going to compare them. Now notice, and we talked about this last week, you need to understand how to work seamlessly between a table, a graph, and an equation that represent the same scenario, because the expectation here in 8th grade is that you can get a situation like this, have a table and an equation, and you could compare them pretty fluently, right? You could easily identify the differences between them. So that's what we're going to start to talk about today.
So printer A, there's a nice haircut table here for you. And printer B, it says the printing rate is defined by the equation y equals 50x. And it says where x is the number of minutes and y is the number of pages. So we need to compare these two to find out which one is faster, which printer is faster, okay? So how can we find the number of copies made in 1 minute using the table and the graph?
Let's start with the table. How can we find the number of copies in a minute if we're looking at a table? What did you just say? It's already up there, because why?
For one, like, you didn't like one for one, like tells you how much.
For one
So
what?
we're looking for the unit rate.
For one what? Like in this context, one what?
1 minute.
Okay.
Good. So you're all really saying the same thing. The beautiful thing here is the unit rate's already shown. It tells us 40 pages for 1 minute. Perfect. How about the equation? How do we know that the equation is y equals 50x? How can we find out the number of pages per minute in the equation? Hold on. Mortimer.
That's basically the unit ARN, but if you want to like elaborate on it more, you can substitute 1 for x, and so you have 1
Minute.
Yeah, 1 minute
Is
oh my god.
it's okay. It's a Monday. I get it.
Okay, 1 minute, for every 1 minute you have 50 copies. Wait, pages.
Yeah. Great. So the unit rate in that equation is what value? Where can we find the unit rate in an equation? Let's use mathematical terms. It's keep going. I know what you're saying.
For one, like you said for.
Well, if you're looking at an equation, where can you identify the unit rate in the equation?
The constant of x.
Constant of proportionality.
It is the constant of proportionality, but it's be more specific. It's the coefficient. Good. It's that coefficient of that variable. Good. So Mortimer, I liked how you said it is that number, but you could substitute in. Right? If I substitute in x is 1, meaning 1 minute, my output or my result would be 50 times 1, which is 50. Good.
Because right here it tells us x is the number of minutes. So when you're substituting 1, you're saying that for 1 minute. It's not always going to tell you things like that. Sometimes you're going to have to look at a graph and figure it out.
But we're starting small here.
Yeah. Okay. So why don't we create a table for this equation for printer B? Y equals 50x.
If we're comparing here, we did talk a little bit about this on Friday. When you're comparing, you're going to be given different formats. You'll be given a table and an equation, a graph and a table. When we compare, it's much easier to have them in the same format. So right now, we're going to take that equation for printer B, and we're going to put it in a table because we may be able to compare them much easier if we have 2 tables side by side. So how would we fill in the table? Go ahead. You're rocking it today.
Okay. So number of minutes. You're starting off with 1.
Good.
So 1. And then 50
Good.
is,
So for every 1 minute.
pages.
50 pages. Who can give us another value of that graph, Giselle?
2.
Yeah.
50 plus 50 is 100. So 100.
Right.
Good. 2, 100. Good. Who can give us another one?
3. And 1.
What's happening every minute?
There's 50
Producing
pages being
50
printed.
more.
Actually,
Producing 50 more
so as our minutes increase by 1, what's happening with our pages? comes into play when we talk about slope, because when you graph it, that's really your growth. Okay, sorry.
I'll do my best.
Can we fill in one more?
Yeah, is there any? 4 and 200. 4 and 200.
Didn't we have to put 4 and 200, or could we have done like 10? 10 and 500. Yeah, we could really have put any value so long as it was proportional to the rest of the scenario. Good.
Okay, so now we're going to take a look at these two tables. We just created this one. How do we use the tables to find the unit rate for each printer?
Now they're in the same format, so we can really identify in the same way the unit rate. We kind of already talked about how to find the unit rate in printer A. Who can reiterate for us how to find the unit rate if you're given a table? Go ahead, Emmanuel, sorry.
It's already right in front of you.
Where? Be specific.
Like in the number of minutes, if you're trying to find how many pages per minute,
Per
1 minute.
1 minute. Good. So let's find out on the table. Printer B and printer A is 40 for 1. Sorry. I thought you were going to go circle it. Perfect. Okay. Perfect. Now see how much easier it is when you have them in the same format to just find it? You have to do a little work with the equation and then a little work with the table, but now it's a little bit easier to compare them.
But it was kind of easier both ways.
Right, so in this scenario, we started with straightforward examples. The examples that you'll see moving forward are a little bit more complex. But you're getting the idea, which is great.
So now we're going to go the other way. So we have an equation for printer B. We have y equals 50x. So now we're gonna make the printer A into the same format, and we're gonna make an equation for printer
Who
A.
can give us the equation for printer A? Myra.
Y equals 40x.
Perfect. And what does that equation mean? Ayan, what does the equation mean? Y equals 40x.
Oh, for every 1 minute, 40 pages are printed.
Perfect. For every 1 minute, 40 pages are printing. Excellent. Fantastic.
Okay, so we can create a graph that has both printer A and printer B on it.
How would we have graphed that? What would we have done to graph that?
We would have followed.
Okay, we could have just taken the table. Can you go back one slide? We could have taken the tables and we could have just plotted the coordinates. So for printer A, when x is 1 and y is 40, when x is 2 and y is 80. And then the same thing for printer B. What else could we have done?
Follow the function.
Good, which is what?
For your x-axis time multiply by 50 equals your y-axis.
Okay, so how would you show that on the graph? For every one we move over,
Yeah.
we do what?
50.
We go up either 50 or, depending on the other graph, 40. Good. You could have used the slope, which we're going to start to get a little bit more into as the week goes on.
This is one. So that's exactly what Mortimer just said. For every 1 minute, we're gonna go to the right and then up for up to 40 pages. For every 1 minute, 40 pages.
Because up on the y-axis represents an increase in the number of pages. Because up on the y-axis is positive.
Okay, how can we find the number of pages per minute on the graph?
Where do we look on the graph to find the unit rate? Where on the graph is our unit rate represented always? Say it again. Where on the x-axis are we looking?
Towards the 1.
Well, right at the one. We want to find where the x-axis has a value of 1. The nice thing here is it's actually a point on the graph. Is it always? No, sometimes you may have to do a little bit of work, but it's where the x-axis gives you a value of 1.
Okay, so what are the slopes for each line on the graph?
What's another word for slope that we talked about last week?
Wait.
There's 3. Slope,
Right.
Giselle, constant of proportionality, and unit rate are the same value. So what's the slope of these equations?
Wait, isn't it also rise over run, right?
Yeah, so that's how we can graph the slope.
I have to say
Stop getting
something.
ahead. Good. So those 3 values are the same. So if we know the unit rates, then we know the slopes. So what are the slopes of these lines/relationships?
What's the slope
For
again?
the first one, it's for every 1 minute, you print 40 pages.
Good, so 40 would be the one, increasing by 40 for every one. And then how about the second one? The second scenario. What's the slope? If it's the same thing as the unit rate and the constant of proportionality, what would the value be for the second scenario?
Increasing 50.
Yeah, for every 1 unit, for every 1 minute, we're increasing by 50 pages. Perfect.
That's so, that's what was so interesting, just telling me.
It's the unit rate.
I thought it was that little thing.
So what's the difference between the per page rate of the two printers?
What's the difference between the two? Ayana, go ahead.
Oh. Plus 10.
Okay, so the difference between them is 10 pages. Which one's faster? Leah? Printer B. How do we know printer B? Go ahead.
Because
There's a few different ways you could explain. So some, based on how she explains, somebody be prepared to explain it another way.
it produces 10 more pages in that minute.
How do you know?
Because it's 50 and A got 40.
So on the table, if you look at the unit rate, the printer B, it's 50 pages in 1 minute, the other one's only 40. Let's say I don't have the table and I just have the equations. What about the equations or the graph? What about the graph?
Okay, on the graph you can see the level of increase is much higher. Like how printer B is increasing way faster compared to printer A that is like slightly moving.
How do you know? What are you looking at?
The graph.
What about the line?
Oh, we're looking at the points.
So look at printer B's line. That line is steeper than printer A. So if it's increasing and it's steeper, what do we know about the relationship? As our units increase on the x-axis, what's happening on the y-axis if it's steep?
They're higher, they're
They're going.
up,
Compare the rates. Steeper means
faster.
faster. Yeah, it's actually going faster the steeper the line. Good.
And then what about the equations? How can you tell them the equations?
If you have y equals 50x and y equals 40x, how would you know that printer B is going to give you more pages? Giselle.
Because it's telling you how much is being.
Right, so it's giving us that unit rate. It's saying every minute, this one's printing 50 pages, this one's printing 40. Is there ever going to be a period of time where printer B is producing less than printer A? No. Good.
Okay, so now in your groups, we're going to take a look at this scenario. It says the price for X pounds of almonds at the Snack Shack is presented by Y equals 6.5X, and the cost at the Nut Hut is shown on the graph. Which store sells almonds at a lower unit cost, and how much lower?
We do not make up the names of these stores. They're provided.
We were like, they're gonna laugh.
All right, so you're given the equation for Snack Shack and you're given the graph for the Nut Hut. You're finding out which store sells almonds at a lower unit cost and how much lower. So think about what we did in the example. We were given an equation and a table and we put them in similar formats to compare them. If you don't need to put them in similar formats, that's okay, but we still need to identify the comparisons. So work in your small groups. If you want to put it on the whiteboard, you can answer on the whiteboard which store is lower and how much lower. Let's say 5 minutes.
I